After a few side trips through rocks, springs, and faucets, our water droplet reemerges in northwestern Oklahoma's Cimarron River. This time the droplet heads downstream toward the sands of Little Sahara State Park. Let's use the Stratalizer to get a view from high above and check out the river as it moves from the mountains across the plains down towards the sea. While looking for our droplet, we notice some parts of the river appear straight, and some are very curvy. And bluffs or cliffs are often formed near the river's edge. The river's size, shape, and behavior is changing mile after mile as it moves across the plains. Why does it do this? Perhaps the answer lies in the land itself. Let's take a closer look. We've landed the Terravator here near this stream. It is not far from where it comes out of the mountains. Let's gather some data here to compare with the other places along the river. The river here appears to be filled with a coarser sand and small gravel. There are many sand bars forming in the river. The river here is running fairly swiftly. The fast-moving water is moving a relatively large amount of sediment downstream. The river here is made up of many channels, with sand and gravel bars in between. The valley is wide and shallow, but the individual river channels are relatively narrow. Looking down from above, we can see the many channels, or streams, within the river, and they change with every flood. The river appears to have a braided pattern, so we call these braided rivers or streams. A braided river or stream consists of a network of channels, separated by small, temporary islands called bars. Braided streams occur in rivers where high-speed water slows down rapidly as the land gets flatter, such as where rivers exit the mountains. The waters exiting the mountains carry a lot of sediment, which drops out rapidly when the water slows down. These piles of sand and rock are constantly being moved and reshaped by floods that occur along the river's course. Here, the river's sediment is a mixture of finer sand and even finer silts and clays. These are smaller grains than back up in the mountains. The water here is slower than near the mountains, but faster than near the ocean. Here, the river has a main channel that's deeper and wider. It also has a sizable sandbar. The river channel is a well-defined, confined path that water takes as it flows within a river or stream. Rivers can contain multiple channels, which split the total flow of water into various areas. Most rivers have one large, dominant channel, carrying the bulk of the water downstream. The river is no longer completely straight, but it's starting to slightly curve back and forth. On one side of the river, the sand and silt are being deposited into a pile. This is called a point bar. On the other side of the channel, the water is moving fast and eroding the land along the river's edge. We call this the cut bank. Point bar forms when the water is carrying sediment and slows down while going around a turn or bend in the river. The slower water drops sediment into a pile, creating rich new land. A cut bank is a cliff or steep bank of the river where water moves fast and erodes the sediment from the side of the stream. This causes water to speed up and erode the bank, picking up sediment and carrying it downstream. Here, the river's sediment is mostly made of very fine muds and clays. Only the finest grains of sediment can make it this far down the river. The lazy river wanders back and forth very slowly here because of the very low slopes near to the ocean. The river has one main channel, and it's very wide and highly curving. In places, the river has even curved back on itself, and a new channel has formed. Oxbow lakes are formed this way, when channels cut off the river, creating a new lake. Over time, the river builds up a wall of mud along its banks. These are called levees. Levees help keep the channel confined and can be either natural or man-made. In times of flooding, these levees can be broken, and naturally, water will spill out over the low-lying land near the river. For thousands of years, floods have occurred periodically along Oklahoma's rivers. Those floods are critically important for delivering nutrient-rich sediment to these areas, called floodplains. Floodplains are fantastic because they have the right soil and soil moisture to let trees and other vegetation flourish. Some of the great forests of North America are found here along the edges of these floodplains. We will examine why levees are so important to controlling flooding as we head further down the Mississippi River. Because these rivers curl and curve back on themselves, wandering across the coastal plain, we call them meandering rivers. Over time, meandering rivers can completely reshape the landscape. Based on the evidence we've gathered, why do rivers look different from the mountains to the ocean? Here at the Arkansas River in Tulsa, Oklahoma, how would you describe how our river shapes the landscape? Rivers are conveyor belts of water, bits of rock or sediment, as well as other things. Rivers grow as they move, as other streams or rivers join them. These rivers are called tributaries. As they flow downhill and join together, these tributaries bring water, sediment, and other things as well to the ocean. Many of the rivers in the central United States are tributaries to the Mississippi River, the largest river by volume in North America. Rivers like the Arkansas River and the Mississippi River it feeds into shape the land by delivering sediment to areas that are lower in elevation. Floodwaters in the Mississippi deposit this valuable load of sediment on its floodplains, building up new land over time. Deep underground, as this land piles up, the water is forced out of the pores through compaction. Along the coastline of the United States, especially here in Louisiana, the land is compacting and sinking. Unfortunately, in the quest to provide flood control, we have an adverse effect, and that is we limit the amount of sediment that can fill in these holes. Let's take a trip to the old river control structure, here north of Baton Rouge, Louisiana. Here at the old river control structure, the Army Corps of Engineers maintains this giant series of levees, dams, and spillways, all here to protect the surrounding landscape from the power of the Mississippi. During periods of flooding, water is rerouted into the Atchafalaya River Basin in order to prevent flooding downstream. Here in the control structure, giant steel plates and locks like the one behind me help hold back the weight of all of the water of the Mississippi River. Millions of cubic feet per second flowing past this point all trying to get down the old river and into the Atchafalaya River Basin. This structure and these steel plates can be raised and lowered to help control the flow of water through this structure. We have followed our river on its long journey from the high snows of the Rockies through the plains and here onto its approach to the Gulf of Mexico. We have seen that the land looks different in each place, as it is sculpted by the rivers like these over many thousands of years. Let's pick up some estimate so we can fuel the Terravator. There's a large city just downstream, and our sensor suggests that our nanodroplet might be there.